Welcome back. In this question, we're gonna solve this integral. So this is a Berkeley math competition question. It's calculus question. So the integral between 0 and plus infinity of 1 over x squared. Okay. If we graph the function here, 1 over x squared. So let's say this is 1 here. So the assume that this is the graph. Okay, so we want to find how much is this value here. So the geometric meaning of this improper integral is that, so this is a positive function, 1 over x squared is positive, and it's here. So we want to compute this integral here. Is it finite or infinite? Okay, I see that the solution says it's 1. I don't know how they get 1. They said it's 1 and it's trivial. It's not trivial for me, and it's an proper integral. Maybe there is a typo there. I don't know. So there is an error. So here we're going to try to solve it in our way. So to start with these improper integrals, we see if there is a problem is this bound. So here we have problem at 0 and problem at infinity. So to get rid of this problem here at 0, we're going to split this because we have two problems at 0 and infinity. So we're going to split this integral into two. So here, this is going to be the integral between 0 and 1 of 1 over x squared dx. Okay, so what's this one here? Let's call this one I, and we're going to call the other one j, between 1 and infinity of 1 over x squared dx. So this is easier. Okay, this is easier because we know that we can define this one as the limit as x goes to infinity between 1 and x of 1 over t squared dt. Okay, here we integrate on local interval, and after that we let that interval we increase the interval. That's what we do here. So we now a primitive of 1 over t squared. So we still have this definition. Okay, so this is minus 1 over t between 1 and x. Okay, and before taking the limit we evaluate. So we have minus 1 over x plus 1 over 1, so which is 1. So the limit here, so this is as x gets bigger, this is 0 plus 1, so we have 1. So this integral is convergent, so this is 1. What about this one here? So the one between 0 and 1. So we call that one I. So here 1 over x squared dx. So here we have problem on 0 from the right. So therefore we take the limit as x goes to 0 from the right of this integral 1 over between x and 1 over t squared dt. So the same thing, we now a primitive here. So this limit, okay, so minus 1 over t between x and 1, and again we evaluate. Okay, so we have minus 1 plus 1 over x. Okay, so this is, we just plugged 1 here. We have minus 1 and minus 1 over 1, which is minus 1. And when we plug x with this minus here, we have the plus. Now, if we take the limit, okay, so what's this limit here? 1 over x when x goes to 0 from right. It's plus infinity. Okay, so this part here is infinite. So here between 0 and 1 and infinite plus this one, which is finite. So this integral is infinite. Okay, so it's not convergent. It's not equal to 1. I don't know how they get the 1, but maybe there is some kind of error. If the integral that we had to evaluate was between 1 and plus infinity, we definitely have 1, okay, as we have seen here. But if it is between 0 and plus infinity, it's not. So it's infinity. So it's divergent. Okay? If you see any errors or mistakes, please let me know. Okay? My handwriting, this is my handwriting. Okay? So if you write a lot, your handwriting will be messy. And it's good to use your handwriting, because if you read from slides, you forget quickly. you forget very quickly. Okay, we're gonna talk about this maybe next time if we have some. So here, try your best and work the problem. Work it yourself before you see the solution. Thank you.